Alright, today we're going to be talking about how to solve systems of equations using substitution. We've already learned one method for solving a system, and that's graphing. We graph the two lines and we see where they intersect, and that's our solution. Today we're going to talk about substitution, and substitution is a way of using algebra to find your solution. So we don't need a graph, we can just use algebra. The definition for substitution is we're going to try to isolate one variable in one of our equations and then plug its value into the other. Now, just so we have an idea of what we're solving for when we go to our next example, I want you to remember that when you're solving a system, if you were to graph your system, you're looking for the place where the two lines intersect. So let's say, for example, that I had something like y equals 3x plus 2 and y equals 2x plus 4. Now, these aren't perfect lines. I'm just going to kind of estimate. If I had a y-intercept of 2 and my slope was a positive 3, I'm going to say it crosses like there. If I had a y-intercept of 4 and a slope of 2, let's say this line is like this. Right? And we're looking for this intersection. That is our solution, like we've learned in our previous objective. We're looking for an ordered pair that is an xy value that we will solve this solution where the two lines intersect. When we do the substitution method, we're going to find the solution without making a graph. We're going to use algebra. So let's do an example. So here I have example number 1. We're trying to find the solution to the system y plus x equals 4 and x equals 4. So first of all, we know that our solution needs to be written in an ordered pair. Biggest mistake, a common mistake that a lot of us make, is that we will find our x and our y and then we won't write it as a ordered pair. So go ahead and write solution at the top, write the ordered pair out so you can get yourself set up. Remind yourself that this is x and this is y, and as we find it, we're going to fill these in with numbers. Now, we need to find x and we need to find y. So I'm going to go ahead and set up my work so that I can solve for x, I can solve for y, and then at the very end, I can solve for a check and make sure that it's right. Okay, so I'm going to go back up to my two equations and I'm going to look and say, okay, are either of these equations solved for a variable? Do each of these equations have a variable that's isolated? And I notice that x is already isolated, so I'm going to put that under here, x equals 4. Once I have one of my variables isolated and I know that x equals something, I can use that to substitute into my other equation to solve for y. So I'm going to go ahead and put that equation underneath y. I know that x equals 4. So I'm going to substitute this in for x. And I put parentheses around this because I want us to remember to use parentheses when we're substituting. So I'm going to rewrite y plus parentheses equals 4. So I know that x is 4, so I'm going to go ahead and substitute in 4 for x. Now I'm noticing that this is a one-step equation, and I have y plus 4 equals 4. So how do I get y by itself? Well, 4 is being added to y, so I'm going to minus 4 from both sides. Bring down my y. 4 minus 4 is 0. That cancels out. And 4 minus 4 is 0. So I think that y is 0 and that x is 4. Now before I move on, I should always check. So the first thing I'm going to do, I'm going to write a 1 and a 2, so remember to check both equations. I'm just going to rewrite each of these equations. Y plus x equals 4 and x equals 4. I think that x is 4. I think that y is 0. So I'm using parentheses. I'm going to substitute in those values. So I put a 0 in for y and a 4 in for x. 0 plus 4 is 4. I got that 4 equals 4, which is the truest statement, so that check works. The second check is a little bit easier because they told us that x is 4. So if x is 4, that means that 4 is equal to 4 because x is 4. That check works. This one is easier. That was given to us. So now since I know my solution works, I'm going to go ahead and write it up here. I know that x is 4, and I know that y is 0. So my solution to this system of equation is 4, 0. Now, you can copy down these two different lines that I'm about to make in your graph, but I want to just quickly show you in one example that if we were to graph this, we would still get the same solution. So I'm going to graph this one first. I have y plus x equals 4. Right now, we know that we can't graph that because the only way we can graph something is if it looks like y equals mx plus b. So I need to rearrange this first. So I'm going to minus x from both sides. And I have y equals negative x plus 4. So I know 4 is my y-intercept, so I'm going to go to 4. I know that I have a slope of a negative x or a negative 1. So I know I need to go down 1 over 1. So I'm just going to really quickly graph this line, and you can just graph this line on your own notes as well. So there's my first line, y equals negative 1x plus 4. Now I'm going to go ahead and graph my second line, x equals 4. Remember that x equals 4 means that it's crossing the x-axis at 4. So it's going to cross right here. So I'm going to go ahead and draw that line. All right, now I have both lines drawn. And if you notice, these two lines intersect right here. Oops, didn't mean to undo that. Those two lines intersect right there. Now, if I were to figure out what that point is, what point is right there? I see that it crosses at 4, 0. So that point right there is 4, 0. That is the same solution that I just got solving this algebraically. So you can see that you can use graphing, or if you don't have a graph, you can use this method of substitution. So let's do another example. Let's take this example. We have 4x plus y equals 2 and y equals 3x. Now again, I know that I want my solution to be an ordered pair, so I know my solution is going to be x, comma, y. And I know that I need to solve for x and y, so I'm going to go ahead and set up my work, x, y, and the check, so that I make sure I check my answer at the very end. Now I'm going to look at my two systems equations and I'm going to say, okay, which of these equations is solved for a variable? Which of these is a variable isolated? And I notice that y is isolated. Y is by itself. So I'm going to go ahead and write that one underneath here. Y equals 3x. I'm going to put my other equation under x because I'm going to use the other equation to solve for x. Since I know that y equals 3x, y is 3x, I can substitute 3x in for this y. I'm going to put parentheses around this, and I'm going to put parentheses here because I'm going to use that to substitute, and I'm going to put 3x in for y. I'm going to write what that looks like. 4x plus parentheses equals 2. I know that y is 3x. So I'm going to put 3x in for y. A couple of pointers that will help you not do common mistakes. You are replacing y with 3x. The y is now gone. Once you get to this stage, there should be no more y's here. Because if a y was here, we wouldn't be able to solve for x. We're trying to eliminate y and get the x's to solve for x. So you're replacing this entire y here with 3x. So now I'm going to go ahead and simplify. I have 4x plus parentheses 3x. Now there's no multiplication here, it's just plus 3x. So I'm going to drop the parentheses. 4x plus 3x equals 2. Remember, you should always ask yourself, can I simplify anything? And I see over here I have like terms. I have a 4x and a 3x. 4x and a positive 3x give me a 7x. That equals 2. Then I say, okay, how could I get x by itself? Well, this is saying 7 times x, so to undo times, I'm going to divide by 7. These cancel out, and I'm left with x equals 2 over 7. Now I have my x, but I still need to find my y. So I'm going to use this equation. If I know that x is 2 over 7, I can put 2 over 7 in for x. So I'm going to put y equals 3, parentheses, because I want to use parentheses. X is 2 over 7. So now I'm going to keep simplifying. Y equals, well, 3 times 2 over 7 is 6 over 7. So I think that x is 2 over 7 and y is 6 over 7. Now remember, before you put your answer out, let's check to see if it works. I'm going to rewrite these two equations. 4x plus y equals 2 and y equals 3x. So I'm going to do this one first. I had 4 times x plus y equals 2. For x, I'm going to put in 2 over 7. For y, I'm going to put in 6 over 7. And then I'm going to simplify. 4 times 2 over 7 is 8 over 7. Plus, bring down my 6 over 7. And if I add 8 over 7 and 6 over 7, I get that 2 is equal to 2. It works. Now to solve for y, to check y, I'm going to do the same. I think that y is 6 over 7. So let's see, is 6 over 7 equal to 3 times 2 over 7? Well, I'm going to bring down my 6 over 7. And 3 times 2 over 7 is 6 over 7, so it works. Both of my checks work, so I can write my answer and my solution. X is 2 over 7, y is 6 over 7. This is really clear in this example why we want to check it twice. If we only checked with this equation, we could have said, oh, well, it worked here. We want to check it with both, because if it works in both, you know that you did your work right. So let's do a couple more examples. Here's another example. In this example, we're not solving for x and y, we're solving for k and n. Now, k and n, what you were solving for, aren't x and y, but we can still solve for those two variables. So I'm going to set this up. I'm going to solve for k. I'm going to solve for n, and I'm still going to check my answer. Now, normally, we would write our answer as an ordered pair. When you're solving for variables that aren't x and y, you aren't going to write them as an ordered pair. You're just going to write k equals and n equals. So, I'm going to look which of my equations has a variable that's isolated. Well, I see that k equals 5n. The k is alone, so I'm going to go ahead and write that underneath k. K is equal to 5n. I'm going to write my second equation under n. 2k plus n equals 33. Now remember, we know that k equals 5n, so I can substitute this using parentheses in for k. So I'm going to rewrite this. First, I'm just going to write out the parentheses without putting that in so I can make sure I did it right. Did I rewrite the k? No, because I'm substituting 5n in for k. The k is gone. I'm going to write 5n in the parentheses. Now here, you should remember, ask yourself, can I simplify anything? Well, I see right here I can do 2 times 5n, which is 10n. I have my plus n that I'm going to bring down, and that equals 33. I still have some simplifying I can do. 10n and n are like terms. 10n plus n gives me 11n. Then how do I get n alone? Well, between 11 and n is multiplication, so to undo that I'm going to divide. These 11s cancel out. I'm left with n equals 3. Now I know that n is 3, so I'm going to find k. If I know n is 3, I can put n in for 3 in for n. So I'm going to rewrite this, k equals 5, and using parentheses, I'm going to replace n with 3. 5 times 3 is 15. So I think that k is 15 and n is 3. Now remember, before we write our answer out, we should check our solutions, and you should always check. So I'm going to rewrite these two equations. K equals 5n, and 2k plus n equals 33. I I think that k is 15, so 15 equals 5 parentheses n is 3. 5 times 3 is 15. 15 equals 15. That check works. Let's do it for this one. 2 times k, which we think is 15, plus n, which we think is 3. And the whole thing equals 33. Well, 2 times 15 is 30. And 30 plus 3 is 33. So my solution worked. I checked. So remember, if we have k and n, we don't have x and y, we're just going to write it as k equals n equals. So we think that k is 15, and we think that n is 3. So we have our solution. Alright, now example 4 looks like an example we did before. So what I want you to do right now is just pause the video, try this on your own, see if you can get it, and then I'm still going to walk you through the whole video so you can see what it looks like. Alright, we're solving for a system. We have x and y values, so we know that our solution should be in an ordered pair. So I'm going to label that out for myself first. I know I need to solve for x. I know I need to solve for y, and I know I need to check my answer, so I'm going to set that up. I'm going to look which one of these is solved for a variable. Well, y is solved for 3, so I know that y is 3. I'm going to rewrite my other equation underneath. Now I'm going to go ahead and substitute in my value for y. So I know that y is 3, and I can put this y in for this y using parentheses. So I have 3x plus 2 parentheses equals 15. Y is 3, so I'm going to put 3 in for y. Now I'm going to simplify. I have 3x plus 2 times 3 is 6 equals 15. Now you should see that this is a two-step equation. We need to solve for x. So first I'm going to undo my plus 6 because I'm using reverse GEMDAS. So I have 3x equals 9. Now I have 3 times x equals 9. To undo times 3, I'm going to divide by 3. These 3's cancel out, and I'm left with x equals 3. So I think that x is 3, and I already had solved for y. It was given, so I think that y is 3. So let's see if this works. So first I'm going to rewrite my two equations, y equals 3, and my second equation was 3x plus 2y equals 15. So y is 3. Well, yes, 3 equals 3. That was given. We know that the y is going to be 3. Let's check our second equation. 3 times x plus 2 times y. Well, x was positive 3. Y was positive 3. 3 times 3 is 9. 2 times 3 is 6. And 9 plus 6 is 15. It was correct. Okay, we're going to do one more example, and then I'm going to have you do some practice. So this example looks a little bit differently, because our goal is always to look for an equation that has a variable that's isolated. But if we look at this example, both of our variables are isolated, so it's a little bit tricky. So what we want to do, first of all, is recognize that we are solving a system for x and y. So our answer is going to be in a solution. So let's write that out. We know our solution is going to be x, y. We're still going to have to solve for x, and we're still going to have to solve for y, but both of these equations are solved for y. So how do we do this? How do we solve this type of problem? Well, the key thing to notice here is that y equals this. Y also equals this. What it's essentially saying is that these two things equal each other. And if I were to take this bottom equation, I could substitute this in for this y. If we do that, the x's are going to be, or the y's are going to be gone, and you're going to be only left with x's. So I'm going to rewrite this first equation underneath here so that you can kind of see how it works, because that one is solved for y. and I'm going to substitute in, I'm going to substitute in this equation for y in order to solve for x. So what that's going to look like is I have this first equation, negative 6x plus 17. This equals y. This also equals y. They equal each other, so I'm going to put them equal to each other. And on the other side, I have x minus 4. Now you'll notice that we only have x's left. If we only have x's, we can solve for x and then use that x to solve for y. So I'm going to go ahead and solve this equation. First, I'm going to get my x's together, so I'm going to bring this 6x to the other side. Notice that, as a little reminder, I'm bringing over the entire thing, 6x. And remember that you're only combining your like terms. So these cancel. I'm going to bring down my 17 equals 7x minus 4. My x's are together, but I still need to get my constants together. So I'm going to bring this negative 4 to the other side by adding 4. Now I have 21 equals 7x. 7 times x equals 21. So to undo 7 times x, I'm going to divide by 7. And I get that x equals 3. Now we still need to find y. So I know that I think that x equals 3. So I'm going to just use the first equation, and I'm going to see if I can figure it out. We don't know y. That's what we're solving for. Let's substitute in 3 for x. I'm just going to write out my parentheses first. I think x is 3. Now let's simplify. Negative 6 times 3 is negative 18. Negative 18 plus 17 is negative 1. So I think y equals negative 1. Now, actually, I have a great reason why it's important to check. Let's say we did something wrong here, and then we put it in here. Well, if you didn't check it with this other equation, you could be wrong, you could be right, you don't know. So let's check both of these equations to see that they work. I have y equals negative 6x plus 17, and I have y equals x minus 4. I think that y is negative 1. So let's see. Does negative 1 equal negative 6 times x plus 17? And I think x is 3. All right. Negative 6 times 3 is negative 18. Negative 18 plus negative 17 is negative 1. That works. Let's see if this one works. I think that y is negative 1. So is negative 1 equal to x, which is 3, minus 4? Well, 3 minus 4 is negative 1. They both work. So my solution is correct. X is 3 and y is negative 1. All of these examples are asking you to solve this system. And if we graphed any of these, we would see that they cross at that same point, just like that first example we did. Okay, at this point, pause the video, and there are 6 practice problems here. It is really, really important right now that you take some time and really work through this. Use the examples that you saw before. If you get stuck, refer back to those other examples and see if you can figure out where you made your mistake. You should come into class knowing that you are right because you should check all of your solutions. If you are still confused, I would go back and watch this video again. So at this point, I would pause the video, try the practice problems, and then go ahead and press play to see the answers. All right, here are the answers to the 6 practice problems. Check your answers. If you made a mistake, you should have caught it in the check stage. If you did not, go back and look at your work and ask yourself, am I doing all of the steps?